So everyone, welcome to this is a bonus because I missed last week and I've been sick and having some rough times. I do appreciate you dealing with me. I had a terrible cold, and it was just would not go away, and it was beating on me pretty badly. Unfortunately, my coworkers, several of them had caught it, and we're just passing it around the department, unfortunately. So it's not COVID, but it's a pretty bad cold that's been hurting everybody. So. But a couple things I want to do. I want to make sure I am clear on how to do your net labs and the resources I've already given you for net labs. Now, one of the things is don't forget, I went in and for every single one of these labs, I actually made you an initial device configuration. So in the labs themselves, there's also the net labs documents here in Word format, so you can just download those and fill them out. But excuse me, there we go. My cold's still there. Inside of each one of these labs, typically you have to load a pre-config file. So something for D1, D2, A1, R1, R2, R3. Well, I've got those in text format for you already. So if you go to do a lab, if you download these files and you open them up, you're going to see that in each one of these, I've got a folder for, wrong thing. For some reason, I was grabbing my... You'll see there's a folder for every one of the labs that are in the class. So if you're doing lab 412, here's the pre-configs for A1, D1, and D2. So you can literally just go Control A, Control C, and then when you do your actual login for the lab for this particular lab, which is 412, you would be able to paste that in. Now, I want to show you something real quickly about doing the lab reservation, because we've had some folks with some trouble figuring out how to make a longer than 1 hour reservation. By default, if you go in here and you do a lab for yourself, so we're in our class, KFC CCNP, and let's say I'm going to do lab 412 MST. If you click here and you just select any time on the red line, that is currently. Now you can go into the future. So if you want to do a lab on Friday at 9 a.m. in the morning, you could schedule a lab for then. But right now, I'm just going to show you how we do it, scheduling it at this moment. So the red line is the current time. But if I click here, you'll notice if I just click submit, the basic lab is an hour, and that's it. It gives you an hour or even less than an hour. All you have to do to give yourself up to 4 hours, each lab can be actually, the most you can do is 4 hours, but then you can actually ask for up to 2 extensions of 15 minutes or 30 minutes each. So they could technically go to almost 5 hours of labs. You just click this drop down here and you just pick a time. So you'll notice now my lab goes from 4:05 p.m. to 6 p.m. So I've got an hour and 55 minutes. The other thing that is important here is that the first 10 minutes or so, it takes time for the system to boot up. And then in the last 10 minutes, it will actually kick you off the system and erase the system. So you've really got about 20 minutes, excuse me, on the front end and the back end that you can't use the system. If I click submit, though, you're going to notice it's going to give me my lab for almost 2 hours. And I could have done it up to 4 hours. So I could have, let me show you again. If I want to go in here, I find the lab I want to do. So let's say I'm going to do the lab 512. I would pick one of the pods, and then I just choose however many hours. Now, I'm an instructor, so I can actually go past 4 hours. You, however, cannot go past 4 hours. So the most you would be able to do would be 5.
It never lets me go more than 2 hours.
And not do what, Ada?
It never lets me choose more than 2 hours.
It does not. Okay. Well, then I may have made a mistake in the class. Let me go. All the classes I create, I usually do 4 hours, but I could have very well made a mistake. Yep, there is a mistake. Should have been 4 hours. So there's 4 hours. So that's fixed.
Thank you.
Now, here's the other problem you're going to have, though. If you do a lab for up to 4 hours, or if you do it, say, for 2 hours, if someone schedules right after you, you're not able to extend your lab time. So even though I've given you the ability to do up to 2 30-minute extensions, if there's any lab that occurs right after your time, you're not able to do that. Okay. So just be aware of that. I would usually schedule 2 hours will let you do 90% of the labs in CCNP ENCORE. But when you get towards especially when you do the hands-on final, I would give yourself an entire 4 hour block. because it's going to take 4 hours to do the hands-on final for this particular course. You'll notice when I go into the class or into the pod, now these items are booting. So all these different devices are booting. And so it takes about 10 minutes for all these devices to boot up because they are real devices. They are not simulations. It's not packet tracer. It is a real device that's booting. But I could come in here now if I wanted to. And since I have the text for A1, once it gets up and running, I can copy this, Control A, Control C, and then I could literally go into A1 and I can go paste to terminal, and I can drop in this config, and all it had to do is go into config T and hit paste, and it would drop all the pre-config in for A1. So you don't have to type all that stuff in. Don't take the time to type it in. Just use these files I've already created for you to dump in the configs and get started. Okay, does that make sense? And I apologize, it was only 2 hours. That's one of the problems with the instructor accounts not being limited by what's on the actual thing. Typically, I make it 4 hours.
Okay, this is Clay.
Hey, Clay.
Yeah, I haven't been doing it. I did it the same way you would do on real equipment and Notepad. I copied the entire file that you created and pasted it right into the router.
Okay.
Yeah.
But remember, what I want to make sure you're seeing, Clay, is again, when you do your reservation, when you go in here to do this reservation, to give yourself more than an hour, all you have to do is pick the lab you want to do, pick the pod, and then just change the end time. You can go up to 4 hours now. So if it's 4:09 and you wanted a 2-hour lab, you can make it to 6:30, and that'd give you roughly 2 hours.
Okay, I got
10 minutes beforehand and 10 minutes.
You don't have to request an extension. The 2 hours is.
Yeah, 2 hours and 10 minutes. You can request extensions if no one else has a reservation after you.
Okay.
So you can't be guaranteed an extension. If you think you're going to need 3 hours, do 3 hours. But now here's an important thing. If you are in the lab and you finish it, okay, so let's say I've done it for an hour and 40 minutes, but I finished the lab in 1 hour.
Yes.
Make absolutely sure you go ahead and end the reservation.
Okay.
Because if you don't, that pod's still going to be sitting there thinking that you're using it, and no other classmates can use it.
Okay. Okay.
So it's okay to do a 4-hour pod or a 3-hour pod reservation, but just realize if you get done early, end it so that your other classmates can use that pod.
Well, one more question. In the text about OSPF, in our instructor text, it said that the router ID can be, naturally a dotted decimal number, but also a decimal number, and they use the number 256. And I tried it on a real route. I have 2900s, and it doesn't work.
No, that's wrong. The router ID on OSPF is set in a couple different ways. Number one, it's going to be either set with the router ID command, and if you do that for either IP, whether you're running OSPF v2 or v3, it's going to be a 32-bit address, and it's 255 is the max. So it's typically you'd make 1.1.1.1 or 2.2.2.2 depending on how you do it.
Have you seen that in the text?
Yeah, you're talking about in the actual text itself?
Yes.
Are you looking at the text online or are you looking at the old book?
And it's in the old book, and it's in our Cisco Academy instructor documentation.
Okay, so it's in this is the EIGRP here. I was looking at EIGRP. Let me see if I can find it in OSPF. It's in chapter 8. Is that where it is?
Yeah.
Let's see. Yeah, you can't use 256. You can use 0 to 255.
It is.
Yeah. Or decimal. Yeah, decimal. That they just mean from 0 to 255, which is technically 256 possible positions.
Okay.
But yeah, you can't use. It's got to be a 32-bit number that fits typical IPv4 addressing.
Okay, and one last question. I'm sure. The videos. Are all the videos in the are all the videos there? Because I found 5 only.
What videos are you talking about?
The class videos.
Class videos are on my YouTube page.
Oh, so I have to go to YouTube.
Yeah, I send those out. I send those out when I do the videos. I usually put them, where's it at? Zoom links for the recordings. So here's where I put the recordings.
Yeah, I have that.
Okay, these are actually the old recordings. I got to put the old ones, but I've been sending them out via email to everybody. I send them out via email,
Okay.
but I'll put them in there too. I'll stick them in there too.
Cool.
But it's basically on my YouTube page. If you go to YouTube,
Let me write this down.
yeah, well, just go to YouTube and on my page, you basically look up Pig Caudal 52 is what it is. You'll find my dog. Here's my page. There's my dog. That's Wookie. And then the playlist is our ITC Fall 23. So here's all of our class. We've got 2 meetings so far. So that's where our meetings are. And that's what I've been sending out to you via email. So each one of those have been getting sent to you via email when we have a class meeting.
I maybe I've overlooked it, but I did not see the videos. I'll look again and just be sure.
Yeah. Well, I'll change these 2 here. I'll dump in the new ones here, so that you've got those there. But I've been sending them out via class emails. As Bernard, Ada, have y'all been getting them? Did you get the class?
Sure, I did.
Yes, yes, I did.
Okay. Let me see. Wednesday, and I'll put these in here too. Wednesday, September. Okay, you got them. Yes, because they've been coming to your email, so you should have seen those in there, Clayton. That's one of the reasons why, again, I'd gone over the.
Could you please resend them to me, please?
Yeah, I sent them to your email that you've got in the class. Actually, I sent them both your Stanley email and the other email that you had placed in class. So. Let's see if this works here. Wednesday. Yeah, I've got two meetings that are in the class that are.
Okay.
Drop that. So if you have not watched these, I would strongly recommend reviewing these because it goes over everything about the class and how to turn everything in and everything else. So let me check, make sure this actually pops up. Yeah, these has got the meetings there.
Okay.
But
Kelly,
I've actually,
I'm in my email now.
okay. So I put them in here too. I put them in the class. So I'll try to post them in here at the same time, but I've been emailing them out.
Okay. Those are only 2 you have.
That's it so far, correct?
Okay, I got it. I got it.
That's the only 2 we've had so far. So, all right. Any other questions?
Yeah, one last question. When we're doing the OSPF lab, it's not assumed that the interface that we're configuring is set for no switchboard because when I was trying to prepare for the lab, I was going to the ports that they wanted and say no switchboard. But when I looked at your configuration, you had already done it.
Well, if it's in the config, if it's actually already been asked for in the pre-config, it may be set up that way.
Okay, okay.
When you look at the documents for the initial config, it may already be set up to where it's that way. So when you're looking at, you're talking about OSPF lab?
Yes, sir.
All right, so if we go look at the OSPF lab, which one? Single area or multi-area? Or
Multi-area.
Okay, so let's go look at the preview of the lab. And you will see that in the pre-config, let's see, that'd be down on the switches. Yeah, see, it's already set up on the switch.
Yeah, okay.
It's in the pre-config. So if it's in the pre-config, then it's there just so it's already set up. That's just basically what you're doing with this is you're just turning the switches into routers is all you're doing.
Okay.
It allows you to put an IP address on the switch port so that the port is, and I will tell you a funny story about that. When I interviewed to work for an ISP, that was one of the main questions. One of the first questions they asked me is if I knew how to turn a port from a switching port to a non-switching port to a routed port on a router on a switch.
Yeah,
no problem. That's no problem. But yeah, it's already in the pre-config, so you don't have to do that.
Okay. All right.
But yeah, like I said, if you copy and paste those pre-configs in, it saves you a whole lot of time versus having to sit there and try to type them in. Don't type those in. Use these configs I've already given you to save yourself those times.
Okay.
And one other thing, if you notice these packet tracer activity files, they are just in here as a bonus. They're not required for you to do them. They're there if you want to do them. Most of them just are exact copies of our labs and net labs. I just dump them in there in case you want to use them.
Yeah, I've done a bunch of those.
So those are not required.
So they're not required, so there's no credit. Now the chapter quizzes,
right?
There's no credit for those.
Well, I mean, you got to do them. You got to go into NetAcad and do the chapter quizzes. They are required to do them. And the reason being that inside of this class, when we get ready to actually try to apply for your CEU credits, if you haven't done the chapter quizzes, they won't give you credit for it.
Oh, okay. Okay.
So yeah, those are required to do it. You've got to do the chapter quizzes inside of here, or the chapter exams. They're not really quizzes, they're exams.
No, I know the exams I'm talking about, but they're quizzes.
I would do the quizzes because it helps you prepare for the exams.
Okay, but there's no credit for it.
No.
Okay.
No, there's nowhere I'm gonna check to see if you did them, but it's not technically in the grade book in Canvas, no.
Okay.
The items in here in the grade book are these items right here, these labs, and those are the main items that will be inside the grade book. And by the way, I did grade some today. I'm pretty much caught up until this week's assignments. So, all right.
The ones that I ran out of time on, will I have an opportunity to do the again?
Yeah, let's go back and do them. Let's go back and do them. And like I said, I even graded one today, and I suggested Clayton, I said, you did everything, but you did it over like 4 different reservations. Just go make you a 4-hour reservation and do that lab over. So I gave you a 0, but you can just go back in and resubmit it, and that will let me know to go grade it again. Okay, now which lab was that? That was I don't remember exactly which one, but it was one of the ones on 6, I believe it. I think it was on 6, but I don't want to pull up the grades and show her, but I can check when we get done at the end. Okay. Well, but you can go, if you log into Canvas, it'll show you that it's been graded, and you'll see the grade. And I left a comment on it too, so I did leave a comment. Okay. Well, I can do it now since I have more time. Yeah. Oh yeah, that's fine. That's not a problem. So everybody, let's talk a little bit about EIGRP. Like I said, this is a bonus meeting because I didn't have class last week and the week before, so we've been fighting my sickness. But I want to talk a little bit about EIGRP as a routing protocol, because back in the day when we first started and learned about EIGRP, many of you may have also heard this. How many of you heard EIGRP described as a hybrid protocol? Yes, I have.
I heard.
Okay. They used to, when the curriculum first came out, they described EIGRP as a hybrid protocol. It is not a hybrid. It is a distance vector routing protocol that uses some linked state features. So some of those features, by the way, are what we call bounded updates. In other words, you can configure the updates to stay within a particular area. They don't call them areas, they call autonomous systems, but it's funny. EIGRP uses the name autonomous systems, but that's not really what it is, because an autonomous system is something very different. Inside of EIGRP, an autonomous system is just a set of routers within which routing updates will stay. We typically think of an autonomous system in networking as a group of routers under the control of a single entity running a single interior gateway protocol. Now, do a real quick review here on just routing protocols in general. Remember, in routing protocols, we've got 2 main sets. We've got what are called IGPs and we got EGPs. Okay. Now, what is meant by an IGP? Internal.
Inside one autonomous system.
Interior gateway protocol.
Yep, interior gateway, and you said it right. It is
inside one autonomous system.
Inside autonomous systems. Yep, inside ASs is where we run interior gateway protocols. Exterior gateway protocols, which they used to actually be an actual EGP protocol, but exterior gateway, okay, are between ASs, so between autonomous systems, which typically means between ISPs or really, really large networks like MilNet, GovNet, those types of things. Now, inside of each one of these, especially interior gateway protocols, we have two subcategories. We have what are called distance vector, and we have another type called link state. Okay. Now, distance vector protocols are typically considered to be less robust, having simpler metrics, having the ability for lower hop counts. One of the oldest ones we know about is RIP. That's a very old distance vector routing protocol, very limited. But we also used to have one called IGP, Interior Gateway Routing Protocol. It doesn't exist anymore. We now have EIGRP, EIGRP.
That was IGRP.
Yep. Now, this one doesn't exist anymore. This is well, it was a Cisco proprietary protocol. This now, while it still appears to be, and most people consider it a Cisco, it's actually an open standard. They've actually published it as an open standard, but most people still consider it to be a Cisco proprietary protocol because they developed it. Now, it's a great protocol. It has some really, really good features. One of those features that EIGRP have is, again, the bounded updates. So you can contain them within an autonomous system. It also has a thing called triggered updates. And by that, it means when a change takes place, that change will automatically be sent out. It won't wait for some timer. Remember, RIP waits every 30 seconds to send its entire route table. EIGRP doesn't do that. The other thing that EIGRP does is it maintains a neighbor table, an adjacency table, and a routing table. So it's got the ability to make better decisions about the pass. All right. Now, under link state, we've got two main ones that we know about: OSPF, which is be a discussion we're going to talk about on Wednesday, and another one's ISIS. And there used to be like the OSI model protocol stack, but nobody uses it. And last but not least, down here under EGP, we have BGP, or Border Gateway Protocol, which is our main and only really EGP that's in use today. Border Gateway Protocol, BGP, version 4. And we'll talk a little bit about it. The CCNP ENCORE only requires you to know a very little bit about BGP 4, but this class expects you to know a great deal about BGP 4. So now the beauty of EIGRP is it does have a very robust metric calculation, and it has what are called successor routes and a successor. A successor route is the best route. So it is the route with the lowest metric. Now, the metric for EIGRP by default is the bandwidth plus the sum of the delays in the links. And I'll show you the actual metric here in a little bit. And there's a way to actually use what's called an enhanced metric with EIGRP, which they do use now for faster links. But whenever you see the successor route or a successor, that is the best path, and the next hop router would be considered the successor for a route. You're going to also learn about another thing called a feasible successor. We'll talk a little bit about it in a minute. The feasible distance is the lowest metric path to a destination, so that's the best path. And then the reported distance is what an upstream router or a neighbor router reports as their distance to a particular network. Now, I want to talk just a second about what is called the feasible successor. Okay, so let's go ahead and look at this feasibility condition. The reason the EIGRP can be super fast is because it contains and holds successor routes in the routing table and in the adjacency table, topology table, really. And that's a neighbor topology. I meant to say topology, not adjacency, but topology table. In that topology table is the successor route, but also inside of there is information about what are called feasible successors. Now, a feasible successor is a route that satisfies the feasibility condition and can be immediately placed into the routing table if the successor route fails. Now, what is the feasibility condition? And by the way, I have a hard time spelling that. Feasibility condition. It is the following. The feasibility condition is when the reported distance is less than the feasible distance. All right. Now, that makes no sense until you start looking at different routes and think about it. Okay. So let's imagine, all right, that the feasible successor is across the top here. Excuse me, the successor route is across the bottom here. So our possible successor would be 256 plus 256 plus 2816. All right. And that is our best possible distance to that particular route. Well, you'll notice the feasible successor here, the feasible distance is 3328 because that's R1 to R3 to R4. Okay, so 3328. R4 also reports that it has a reported distance of 2816, and it reports that across this top route here. All right. Now, because R4's reported distance is less, and it must be less, it can't be equal, it must be less, because its reported distance is less than our current successor, that means it can't go through the successor to get to the network. Think about that, okay? So let's pull this up again, and let's think about this feasibility condition. All right. So if we've got this network here, and we've got this concept, or we got this that we've got going on here, okay? All right. If I say that my reported distance is 2816, and the feasible distance is 3328, okay? And so this is what's happening here. R4, okay, which is this router over here on the far, right down here, R4 is saying that R4, to get to the network on the right, it gets there with a reported distance of 2816. The best route for R1 to get there is 3328. So if R4 was looping back through R1 to get to this network, it would have to have a reported distance of greater than 3328, because it would add this amount of distance, that distance, to its information. Does that make sense? Because it took me a while to get that in my head and kind of see that. But once you see it, it makes perfect sense. This is a successor route, a feasible successor route, because there's no way that it comes back through R3 and R1 to get over here, because the reported distance is less than the best route. Now, here's something else interesting. Even if it is a higher number, it does go in the topology table, but it doesn't sit there as a feasible successor. So it can't automatically go into the routing table if the successor route fails. What happens is you have to go through a calculation with the metric. Okay. So when we look at the topology table, we do a show IP EIGRP topology. Let me zoom in a little bit because that'll be a little bit easier to see. When we look at our topology, we're going to see a, by the way, passive state is good in EIGRP, because passive means it has settled upon a successor and feasible successors. If a route is active, it means it's actively running the EIGRP algorithm to try to find the best path. But you'll see here we've got one successor, which feasible distance is 3328. And then there is a feasible successor because the reported distance is less than the feasible distance. So we have our successor route and our feasible successor on R1. So if this top route failed for some reason, this second route would immediately go in the route table. And it wouldn't have to go into active mode. It wouldn't have to go through and do a new calculation. It's going to be sitting there already waiting to go in. This is why in most circumstances, EIGRP can recover in mere seconds from down links, which is really interesting. Okay. EIGRP does use a neighbor table also, and so it sends out hello packets to discover its neighbors. It has basically these different types of packets it can use, these 5, a hello, a request, asking for specific information, an update, which basically is used to send information if there's a change or to a request, a query searching different paths. I need a path for network A. Here you go. And then replies sent to queries. So those are the 5 main EIGRP packet types. Now, this looks very confusing because this is the classic metric. There's the new metric basically multiplies this by 256. But this is the classic method with different K values. And each one of these K values represented a different thing, such as MTU, bandwidth, delay, reliability. All of those items were part of that. But by default, all the K values end up dropping out except for bandwidth plus the sum of the delay. And that's really what it comes down to. And with the new metric times 256, which is called the expanded metric. So what it ends up being is it's the minimum bandwidth in the path, all right, plus the total delay in microseconds. Yep, that's it. Sorry, my phone was ringing on me. So each one of these, it looks at the delay, and then it looks at the link speed. It'll take the slowest link speed and the sum of all the delays in the path, and that will be used to determine the metric. Here's our classic interfaces. So you notice that 64, 1000, 10 gigabits, 10,000 link speed, delay is 10 microseconds, and then you look at your different metrics across those. The new wide metric basically multiplies all of that composite by 256, which lets us be able to use things like 40 gigabit Ethernet, 100 gigabit Ethernet, faster gigabit interfaces. Otherwise, if you didn't do this, pretty much anything above 10 gigabit would appear to be the same speed. So they had to make a wider specification. And that's really what's in use today is these wide metrics. But it still is the lowest bandwidth in the link plus the sum of the delays. All right, is what falls through when it's all said and done. Actually having to do a bandwidth calculation, they do take you through that process. I would probably know how to do it, at least know the basics of how to do it. If you get a question like that on the exam, I don't think you will, but if you do, the big thing is don't forget it's microseconds, and it's also 10 to the 7th, and divide your bandwidth into that. And it's the slowest bandwidth in the link. By default, EIGRP does support equal cost load balancing, but it also has the ability to do something that other protocols can't, like OSPF. It can actually do what's called unequal cost load balancing. You can put in a number called a variance, and if the different paths are within the variance, then it will actually see that as an equal cost path, and it will load balance across more than one path, even though they're not exactly the same, which is a neat little trick. That's not something that OSPF can do. OSPF can only load balance across equal cost paths. All right. Now, the hello packets are used to not only see your neighbors, but it's also there for a basically a health monitor or a check to say, are you there? Yes, I'm here. You're there. There's also a thing called a hold time, the hello interval, and the hold time. By default, the hello interval is every 5 seconds on high-speed links, 60 seconds on slow-speed links, and then the hold time is 3 times the hello interval. Now, here's something that's also different about EIGRP versus OSPF. In EIGRP, if 2 different routers have different hello and hold times, they will actually negotiate down to the slowest. However, it is highly recommended to make sure you don't cause problems, that if you change a hello time and a hold time on one of your routers, you change them on all of them. It's also pretty much one of those things that says, here's how to change it. Don't ever do it unless you're told by TAC to do so. So just be aware of that. It is something you don't really play around with unless you're having issues. If you're having issues with your network, you may change the hello and the hold timer. I would know these defaults, so 5 seconds for high speed links, and then 60 seconds for slow speed, and then 3 times the hello for the default hold time. And what does the hold time mean? That's how long it will wait until it marks a neighbor is not available, and basically removes them from their neighbor table and then the topology table also. The algorithm that is used is called dual, which is the diffusing update algorithm. If you ever wondered why EIGRP has D in the route table for its information, it's because of the diffusing update algorithm. It's because that's what's used. Again, passive is good, active is bad in EIGRP. All right. Now, the good news is EIGRP can converge extremely quickly. I've seen networks converge in up to 5 seconds. Fairly complex networks will just converge in no time. That is because, unlike many distance vector routing protocols, they don't wait a set amount of time to send their tables out. As soon as they boot up, they send their table out, but they still only send them out to their directly connected neighbors. And then those neighbors send them to the next neighbor. So be aware, it's still a distance vector routing protocol. It's just got some special features to make it a little bit better. It does support route summarization, which is like a summary aggregate route, the ability to take and say, instead of advertising these 4 routes in here, I'm going to advertise only 172.16.0.0/16. Now, that is not a great summary for this particular setup here because you've got a 172.16 that's external to R2. But R4 is connected directly to that, so you could get away with it because R4's got a longer match. I would say that if I did this type of summary address, every 172.16 is got to be to the left-hand side of R2. There cannot be any other 172.16s to the right. It's okay with this 172.16.24 between R2 and R4, again, because R4 has got a directly connected connection to that network with a /24, and that will override the /16. But you have to be careful with your summaries or with your summarization. Remember, it has to, if you say that that's where it's at, all the routes have to be in that particular area. If not, you can end up what's called black holing your traffic. And with a black hole, what happens is it goes out there and it gets dropped, and the router then won't tell anybody about it because what happens when you do a summary route is you actually get a route to 172.16.0.0 to null 0. And if something comes in and you don't have a route to it, it gets dumped in the bit bucket and it doesn't even tell the other router. So you have to be careful with summarization. Questions about EIGRP? Questions on the labs for EIGRP? Any problems with them? Okay, so we look at any of the labs for EIGRP. Everybody's good on those? So no real problems? Okay. There's not a whole lot you can do. It's so simple. I mean, it's a simple protocol to actually work on. So there's really nothing to it. Let's go ahead. We got a little extra time. I got through that quicker than I thought. So let's talk a little bit about OSPF. Any questions? All right. OSPF is a linked state routing protocol. Now, this is a different beast. It still has a neighbor table, a topology table, and a routing table. So it does have that. It uses the shortest path first algorithm, SPF, makes sense. And it is, as a linked state routing protocol, it is designed to do triggered updates. It floods its entire route table to everyone, not just to its directly connected neighbors. Actually, it multicasts it out. And so we'll look at what OSPF is and how to do basic configuration on it. So it is an open standard. There are multiple versions. Version 2, which supports IPv4 only. OSPF version 3 supports both IPv4 and IPv6. We also have 2 different ways that you can actually configure it. You can do it with the classic way, or with what's called named, or with address families. We typically do OSPF version 3 with address families, and they will talk to each other. If you do one way, one another. There's somewhere in the curriculum it states that if you do one with address families and one without, they won't talk to each other, but that's total bull. They will talk to each other. I've seen it happen many times. So here is what's called the link state advertisement. So when all the routers boot up, they take their links, their directly connected links, take that information and they flood it out to everyone on the entire network. Then everyone takes that information and builds what's called a shortest path first tree to each individual network. And that tree is based upon the metric, which is cost. And cost is based upon the speed of the link. OSPF has the same issue. It's called the auto reference cost, the auto bandwidth reference cost. That's the same issue as EIGRP with super fast links. If you've got 20, 30, 40, 100 gigabit links, you're probably going to have to change your reference cost to support so that a gigabit link and a 10 gigabit link and a 40 gigabit link don't all appear to be the same cost or speed. OSPF does use areas, and with areas, the beauty is by default, inside of areas, information when a route flaps, other than inter-area communication, where it will give a summary or an actual route information to another area, it stays within the area, or you can configure it to stay within the area. But now by default, it doesn't. It actually goes as a what's called a network LSA, and it goes to the other areas. But by default, you have to always create an area called area 0. That is your backbone. All areas have to connect to area 0. Now, you can do what's called a virtual link, where you can create basically a tunnel to make another area connect that's not actually directly connected to area 0. And any of the routers that are in between areas are called area border routers. And that just means a router that's in more than one area. So it'd be in area 0 and in area 12, area 0, area 34 in this particular case. Now you will notice that by default, these areas do send their information between the different areas. Now there's ways to create summaries at those particular boundaries. And the reason we want to do that is, imagine that area 12 consisted of 50 routers in Chicago. Area 34 is 40 routers in Charlotte. Area 0 is your main office in Indianapolis, okay? And so you don't want to route flapping in Charlotte to affect your network in Chicago. So you summarize between area 0 and area 34 so that a single flapping route in area 34 will not affect area 0 and will not affect area 12. Now, if a large number of routes go down, or an entire set of routes go down, then yes, that needs to be advertised. But the idea of areas is to make areas within which route table updates are contained so that those other routers in different areas don't have to process it every single time a route flaps. Do you know what I mean when I say a flapped route, or when a route flaps? What does that mean?
Off and on, up and down.
Up and down. Interface drops, comes back up. You lose a circuit on an MPLS. You lose a circuit on frame relay. We don't use much frame relay anymore, but let's say you lose a Metro Ethernet circuit. Something goes down. You don't want that. Let's say somebody cuts a Metro Ethernet circuit in Charlotte. You don't want that. You don't want the routers in Chicago running a shortest path first calculation to figure that out. Okay, they don't care for the most part. Now they may still send stuff there and it gets bounced back, but you need to control that because of the size of your networks. You will notice that OSPF uses multicast. You do need to know these two multicast addresses. I've seen questions on this on so many different types of exams. 224.0.0.5, which is all OSPF routers, and 224.0.0.6, which is all designated routers. And we're going to talk about DR routers. DR routers are OSPF routers that have a special function inside of broadcast networks. So networks such as the Ethernet, it's typically just our Ethernet networks that we have designated routers. We have 5 different types of packets, and those packets are, number one, hello packets, which act just like they do inside of EIGRP. They're used to determine who your neighbors are and make sure your neighbors are up. That's their main function. You have database description, DBD or DDP, and those are the summarized database contents. When adjacency is formed, this is me flooding out my database information to my different routers, all the OSPF routers. By the way, I flood that out to 224.0.0.5. So all routers will get that if it's non-broadcast. If it's broadcast, I'll send it to the DRs, then the DRs will flood it out to 224.0.0.5. Link state request is if I need to know about a particular link. Okay. Link state update is a response for a specific network. And then link state ACK is sending an acknowledgement. When a link state request or an update's been received, I can acknowledge that particular thing. Now, for OSPF to work correctly, you do have to have a router ID. Now, router IDs are interesting because OSPF and pretty much all router IDs, this is how they're number one, they're either set with the router -ID command. So you can set it with that command. So if you set it, it overrides everything. Nothing else will matter. If you don't set it, okay, so you don't set the router ID command, your router ID becomes the highest IP address on a loopback. Now, if there are no loopbacks configured, it then becomes the highest IP address on any physical interface. Does anybody know what happens if none of these are present?
It won't establish.
It won't run. It will not run OSPF. It will tell you cannot start the OSPF process when you try to start it. Now let's see if Packet Tracer will do this for us, and I'm pretty sure it will because the last time I did this, it gave me the error message. Let me get Packet Tracer up and running. My machine's being slightly slow today. So if I take, oh, wow, I got to log in. Give me just a second. I got to log into my Packet Tracer because I haven't been in it evidently in a while. Also changed my Cisco password. A couple weeks ago, some of us got enrolled in a class. Yes, it does have to be an active interface. Yeah, active interface. That is correct, Brian. Yeah. So if we bring this out and we bring out let's just throw a switch out here just so we got one. And we'll do a quick gigabit to here. All right. And I'm still going to bring up the interface. So I'm going to go let this thing boot. Yes, it does have to be an active interface, Brian, which that is also, I've seen people put IP addresses on interfaces and forget to do a no shut. They try to run OSPF and it doesn't work, and then they don't know why, and it's because the interface is not active. So let's see, config T, host R1. Let's go int gig 0, no shut. All right, so we got, let's do a do show IP int brief. You can see I've got my interface up and running. But now if I try to do this, if I try to go router OSPF 1, you'll notice cannot start. There must be at least one up IP interface. That is because it has to have a router ID. Now, if I go in here and do this, router ID 1.1.1.1, okay, exit, and then do router OSPF 1, it's fine because it's got a router ID to use. Now, you still can't advertise any networks, but the beauty is it's at least running. So you can set the router ID and then it will actually start the process. By the way, they call this, that's just a process ID. That is just a place to hang the OSPF process. That's all it is. It's a place for it to sit in memory. It's not an autonomous system number. It is literally just a process ID. You can run multiple OSPF processes on a router. There's different reasons you may would do that, but you can do it if you want to. Okay. So just be aware, if you ever get that error message right there, you must have at least one IP. It's because of this. It's because your router ID is not set, or you can't set the router ID, or haven't set it yet. Okay. Questions about that? All right. Inside of each one of these hello packets is that router ID, which is why it's required. Authentication options, if you are running any type of authentication, so if you're doing clear text or MD5 authentication, it's inside of the hello packets. The area ID that this particular hello is associated with, the interface address mask, so the mask of the interface priority. We'll talk about priority for DR elections a little bit later, but it's safe to say it's used for DR elections. It's used to break ties if there happens to be a tie. The hello interval, what it is in seconds, and then the dead interval, which is the same as kind of like the hold time, and then whether or not there's a BDR or DR, which are our designated router and backup designated router, and a list of the active neighbors on the segment. It's important to note that in OSPF, the hello and dead intervals must match. If they don't match, you will not form a neighbor relationship. That's different than EIGRP. With EIGRP, they will actually negotiate down to the lowest. OSPF will not. OSPF, it must match, or they will not form a neighbor relationship. And then that's one of the first things that will happen is when two OSPF neighbors exchange information, they start out in a down state. They then will send out their hello packets to one another. And if you've ever seen, there is a condition called stuck in a knit. Okay, no problem. If you got to go to class, that's not a problem. There's a if you ever see two routers that are stuck in a knit, in other words, they're trying to form an OSPF relationship between one another, but they both say a knit. More than likely, what has happened is you've got a hello packet that went one way, but it could not come back the other way, and so it's sitting waiting for bidirectional communication to be established. If everything works correctly, you'll go very quickly from a knit to two-way, X start, exchange, loading, and then full. And that's where with the exchange is when you're exchanging your database packets, loading the link state requests for anything you don't have that you need to know about. You'll be asking with LSRs and getting LSUs updates. And then last but not least, when everything is agreed upon, the databases have been shared, the links are known about, you built your SPF tree, then you'll go into a full adjacency, and you'll be a full neighbor with one another. Typically, you got to get that full neighbor relationship, then you're going to build your entire tree and then put things into the routing table. So you'll build your topology table after that, then you'll build your routing table. But that can also be taking place during this process of when you're exchanging information. Okay. No problem. No. What I'm actually going to do, sorry, Donald, but I'm actually going to stop right here because I want to pick up on Wednesday with a discussion of DRs and BDRs and how they work on multi-access networks for OSPF. And we will go on through and we'll actually work on a configuration. We'll do a quick OSPF configuration and play with that. And then we will look at OSPF multi-area. Okay. Any questions about what we went over today? Okay. Remember, I did drop the old recordings, our current Zoom recordings in here. I will put this recording in here also, but I will email it out to you. Okay. And make sure you get that too. So check your email. I am sending emails to everybody. We will meet at 4 o'clock on Wednesday. And we'll just go from there, buddy. Any questions?
Thank you, Kelly.
Oh, you're welcome. If you do have any problems or issues, let me know. Like I said, give me about 10 minutes and I'll get this this recording posted. It takes me about 10 minutes to get it uploaded to YouTube. I'm going to stop the recording now.